All right, welcome back everybody to, this is William Briggs. We're going to be continuing our class of uncertainty and probability theory, the logic of science, and continuing our lecture of what probability is. And we're going to come to this idea. Nothing has a probability. Now, this is absolutely true. Nothing has a probability. I was listening to this podcast, a guy named Keating, who's some sort of cosmologist, and he had on a fellow named, I think it was Frank, who wrote a book on the search, something on the search for other life, or whether or not there were other life existed in the universe and this kind of a thing, even molecular life in the sense of chemical, material-based life, even microbes, anything like this. And they were praising the idea of using Bayesian analysis. Well, I'm going to start off with a probability of 0.05 or something like this. And they say it's all having to do with where you start with your priors and all this kind of a thing. Well, those kind of statements turn out don't have any meaning. They're just statements thrown out there. They're not what probability is. We're going to learn exactly why nothing has a probability. There is no probability that life exists elsewhere in the universe. There's no probability that life exists here on Earth. There's, as strange as that may sound, there's no probability that you will be struck by lightning. There's no probability you have cancer. There's no probability that you're alive right now. Nothing has a probability. We're talking about logic here. In fact, that was the homework I gave you. I said, see if you can derive a probability of some proposition that was unconditional, like life exists on Earth. You can't. You can't envision that probability without putting in some sort of, I see it, I measure, and therefore the probability is 1. We have to have conditions. All logic works in this way, and probability is just part of logic. We can't just have probabilities that come out of nowhere. That is both the Bayesian and frequentists believe this. Bayesians in the subjective Bayesian interpretation of Bayesianism, and frequentists just think everything has a probability, that somehow things have inherent in them probability. And they'll speak of true values of probability parameters and the like, and they're trying to estimate these true values that exist in nature. Well, these are parameters of probabilities, which means things must have, like they must have probability like they have mass or energy or weight or length or breadth or quantity or something like this. It turns out not to be true. It just isn't true. And in fact, we have plenty of support for this, but the logic. Finetti wrote this book, it came out in 1970, in English anyway. Very famous book, The Theory of Probability, in which he very famously, I don't know if you can see it, let's see if I can get a camera up there. Maybe you can't, but it has big, bold, giant letters. Probability does not exist. And he has been misunderstood by most ever since he wrote that. James didn't misunderstand him. Franklin, Cox, Jeffries even. It's always strange, isn't it, that it's physicists who seem to come to a more proper understanding of probability before mathematicians. Mathematicians tend to reify their equations a lot more easily than physicists. On the other hand, physicists also get it wrong about quantum mechanics, a lot of them, and they think that quantum mechanics probability exists. So we'll get into all that. So this just isn't true. So, and I'm going to prove it to you some more today. So let me erase all this. And tell you the broad forms of probability. What have we done so far? All we've done is showed that some things are certain in life, some things are uncertain, and some things are certainly false. We learned that our highest form of knowledge comes from inductions, intellection induction, intuition induction, all the way down to probability induction. That logic is, as we're going to see, just exactly what it's going to be, so I'll say that for a moment. And probability can be we have proved that probability can be a quantification of our uncertainty. And the only numbers we looked at so far, the only numbers we've deduced that we proved that probability can be is 1 when things are certain and 0 when they're false. All right, well, that's both certain kinds of certainty. 1 when they're true, 0 when they're false. Next week, we're finally going to get back to Jane's, and it's complex, how to justify numbers being assigned to probability, but we'll get there. And it's not going to be a secret. It's going to be exactly what you think it is, but the proof to get there is somewhat complicated. Now, all probability and all logic fits this schema. In logic, we write the equation like this. It's the same thing. We just turn this 90 degrees to the right, and we stick the probability symbol in front of it to tell us that we're calculating an uncertainty. But logic is like this. You don't hear of logical equations without conditions. No, there's always conditions, even if it's just your senses, as we learned when we were looking at induction, intuition and the like, that tell us whether or not certain things are true, like axioms. We learned from examples from our senses, and then we posit axioms that we know are true. We know are true based on intuition alone. There's no empirical verification of these things. Now, again, not everybody can necessarily follow every axiom. Just because a thing is true doesn't mean everybody can understand it. That's an entirely different thing. People's level of understanding is entirely unrelated to whether or not it's true. All right, so all probability schema looks like this. So we could do either one of two things. We start with a P, and we try to find Q that are probative of P, that tell us something about P. Or, obviously enough, we start with Q and find a P that best fits the Q that we have. And also we're trying to judge evidence where the Q we're using is either high or 1 or something like this, where we're taking evidence of the external world. This is what the questioner asked last week. We went over that to the beginning of lecture number 8, so go back and look at that if you can't remember. We want to find something that's like this. And so really what we're judging is QE, there's another thing here. But we did all that last week. So now we're just going to go through this schema. You can't write a probability that's unconditional. All probabilities have conditions. What happens is subjectivists, like those guys who were trying to find, I'm going to start with the probability of other life existing at 0.05, one of the guys said. 0.05. All right, well, whatever. And then they move through some calculations. Well, what does this come from? It doesn't come from anything. It's just purely made up. If the guy had a bad burrito for dinner, he might have came up with 10%. Or 2%. It doesn't, it's all based on feelings. It's feelings-based logic goes exactly where you think it goes, not to good places. So we're not going to use feeling. I'm going to prove all that later. So when we talk about subjective probability, I'm going to use exactly those kinds of things. So let's do some examples here to show you that everything fits that schema. So let's pick a proposition. We'll pick some evidence, and then we'll calculate the probability of that proposition given that evidence. Now remember, of course, the proposition of interest, the thing we're always interested in, that's subjective. We pick it. It's our interest. And the evidence that we pick, the assumptions, the premises, all of that stuff, the conditions, those are subjective. This, however, is rigorously objective. Absolutely rigorously objective. So for instance, if I had an equation x plus 7 equals 11, that's my Q. I'll write it as a logical equation. And my P is x equals 3. I've just picked these arbitrarily. Now, would you stand for somebody saying the probability of P, maybe loosely not or not given Q, is, I don't know, 90%? Would you stand for that? If you were a professor, a teacher, or even a parent trying to teach your kids some basic middle school or whenever they do this kind of algebra. If not, then you're a rigor. You're a rigorous. You're very logical. You're moving into this equation and saying once these are given, we can no longer subjectivity's out. But a subjective probabilist can say something like this. They can say whatever they want. That's because it's subjective. So we're going to move away from this thing, and so we do have subjectivity here, but once we get to this point, it's hard logic, hard rigor. It's completely objective. It's just a deduction that we make. Okay, so I'm going to use this. I use this in the book, and so I'm going to continue using it. You know, it's sports, it's entertainment. I understand all that. But everybody seems to understand sports. So for that reason alone, I'm going to use it because it's ubiquitous. I'm not going to go in and start talking about two-slit experiments and stuff like this when not everybody will have a physics background or something. But everybody has heard of sports. And, you know, they have one team playing another team. And I'm very much interested in whether or not the Tigers are going to win. All right, so let's think about some evidence. I want to find a Q. This is the first step. I come up with a proposition. I want to find some evidence. All right, how about, well, Tigers win or Tigers lose. What probability may I deduce from saying this? A lot of people will be tempted to say a half. But that's not true. This is a tautology. Basically, all we can get from this is that this event here, this P, is contingent. Contingent meaning, as we went over before, that it's not logically necessary. We don't have a local truth or a necessary truth. And we don't have a necessary or local falsity. In other words, it's not certain the Tigers will win given this, and it's not absolutely certain they will lose given this. We can't say anything. This is true. This tautology, that the Tigers win or the Tigers lose, is true no matter what. This is a necessary truth. It's true even if there are no Tigers. It's just a necessary truth. And a necessary truth, with one twist here that I'll give you in a second, is like multiplying a equation, like that algebraic equation I gave a minute, by the number 1. It doesn't change anything. The one thing we get out of here, though, is the tacit premise that the event is contingent. We do get this tacit premise. It's there, but we never wrote it down. So this Q is really the Tigers win or lose, and the game is contingent, meaning the universe is not set up so it's necessarily true that they win or lose. And so all we could do is this interval. That's it. That's the probability. Now, I haven't proved to you yet that we could do numbers, but we'll get to that. But, you know, like I say, it's not going to be a surprise or anything like this. Okay, let's suppose they won, instead of this evidence, they won 4 out of the last 5. And then you might think, okay, given that that's the case, you might think the probability they'll win this next game is high. I'm probably bouncing in and out of the thing here. I have this new setup. I just have it on you can see I fixed up you can't see everywhere, but I fixed up the entire shack. Did the floor, and the walls are now done. The bookshelves are just bare wood. I haven't even had a chance to treat them yet. The board bounces a little bit. I haven't fixed that up yet. And I have this just on a cardboard box right now because it's still kind of helter-skelter, but I'm getting there. I'm getting there. All right. So that makes sense. Maybe you might even assign a number to that. Well, we haven't learned how to do that yet, but you could say something like this. But suppose then they lost 8 of the last 10 times to this particular team that they played them. And you might think the probability is low. Or you might think, well, let's see, the ERA of our guy is 1.9 and their guy is 2.2. And you might think the probability, therefore, is mid. It all depends on which evidence you assume here. Now, I could also say, I could say something stupid, like the Tigers win. I could put this in here. I can assume the Tigers win, and then the probability is 1. Okay, so this is a true equation. So we're not just trying to find a Q that gives the probability the most extreme, either 1 or a 0. because we know this is false given external information, given the way the world works and so forth. So we're not just trying to pick evidence that, that will give us a very high or a very low p. No, we're trying to find evidence that is true or suspected to be true in the way we did last week, that concords with observation and everything else, and therefore we can derive our probability. Now, if I had the cause, if I knew the cause, all of the causes and conditions that go into the game, well, then the probability would either be 0 if I knew they were going to lose and I could prove they were going to lose in some kind of mathematical, sociological way, or if I prove that they're going to win, I can get a probability 1. That's if I knew the cause and all the conditions. This is our goal. This is the big secret, the big reveal here. Our big reveal is that we're always after the cause and the conditions which give rise to the cause, that let these substances use the powers that they have and produce effects that we can measure. That's it. And so we're going to have to discuss all that kind of a thing. But this is the reason gambling exists. This is the reason gambling exists, because nobody knows exactly what the cause is. There's lots of correlates to cause. You could paint yourself a mental picture about each of these pieces of evidence that tells you about the cause or conditions of the cause in one way or another, without being definite on any of these things. And that there are disagreements is why people bet on these kind of things. So some people emphasize evidence one way, and some people emphasize evidence a different way. But when they agree on the evidence, this is another reason we'll talk about subjective probability. When they agree on the evidence and they agree on the proposition of interest, then it is impossible that they can disagree on the probability, because the probability at that point would be fixed, whatever it is. All right, so let's do the next one here. So let's reverse these. I hope you're getting this. If you're not getting this, you have to ask me questions. I was asking the powers that be. I may be able to, you guys tell me. I'll put this in the notes too of the class on the site or Substack. Maybe I could set up the computer here and do some kind of live stream of this where I have an audience as I'm recording these kind of things. So we'll have to set up fixed time and date and all that kind of stuff for each one. And then I can have people actually shout out questions to me or write them or something like this I could see. Because when I don't have the feedback, I don't know what's going on. And I don't think these classes have quite caught on yet. And I think, I'm hoping that they will. Dust. And then we'll get more people interested in this kind of a thing. So we're really trying, I'm trying to go as slow as I can so I can bring as many people along as I can. But I'm warning you, it is going to get complex, okay? But if I don't do this stuff from the basics, then the disagreements when you try to jump to the right answer, when you try to jump to the end and think, I know how I'm going to use this complex model about, coupled global atmosphere ocean model or something like this, and you think, here's what I think it means. Without thinking about the basics first, you're going to make mistakes. People do. Okay, so now here's we're sometimes presented problems where we have evidence in front of us and we want to find the best P that fits it. So we come in, so suppose we're a cop, dead eraser, and we see Mr. Body dead in the library of some big mansion with a knife sticking out of him. Oops, knife, K-N-I-F-E, okay, whatever. Spelling doesn't count. It's my enemies who make these kinds of mistakes. I don't know where they are, but they do this. If we have only this evidence, now we want to know who done it. We want to know what P accords best with this Q. Well, we could say, your favorite celebrity. Your favorite celebrity. Listen, always listen to celebrities. You have moral questions, go to celebrities. You have questions of politics, listen to our best celebrities. You want to know how the world works, whether or not climate change is something to worry about. You cannot go wrong by listening to celebrities. Celebrities are our leaders. I mean, they know where to stand. They know how to emote. They know how to speak lines that are written for them. I mean, why wouldn't you trust these people? And this is your favorite celebrity after all. So how do you think they did it? Well, there's no way to get to this probability here except like a 0-1 kind of a thing, again, because all we have is a contingent event. We have nothing about your celebrity being here except the tacit premise that somebody did it, meaning some person did it. That's a tacit premise, and your favorite celebrity is probably a person. Who knows? Could be AI these days. I mean, so that leads us to this kind of a thing right here. But because it's your favorite celebrity, you would add this tacit premise, no way, and you'd come into something that was very close to 0 or no way. All right, so that doesn't fit. So, all right, we've got to do something else to this. Well, we have that tacit premise I'm going to erase only because of board space. I'm erasing it, but it's there. It's in our minds. To say that there were 18 possible people on the grounds and who could have committed the deed, and that the butler was one of them. Well, we could say, and it's not going to be any kind of surprise, but we can't calculate this yet, but it's going to be something like this. It's going to be 1 out of 18. Using only this information that we know, we're assuming for a fact. Is it true? Maybe there was a sneaky person, Mr. Number 19, who made his presence unknown to everybody and couldn't, you know, the least likely suspect. That's who did it. Or the highest paid guest star. You can't go wrong with either of those. And the highest paid guest star could be your favorite celebrity. So maybe you have to rethink how you think how you do this. So using this kind of information, it could just be the butler. But what you're going to try to do is that this process isn't static. You could just quit right there. But what you're going to try to do is you're going to try to find evidence, more evidence. You're going to add evidence. I guess I should say add evidence here. And hone into this P here. Of all the list of P's you got P1, P2, however many P's that you have, you're going to try to narrow down this list of P's. So in the end, you have a probability that's somewhat high with the added evidence that you have for the particular P that you're thinking about. It's 1 for one of them, say Pi, and it's going to be low for the other ones, for all the other Pj, for all the other J that don't equal I, if you want to be geeky about it. In other words, what are we doing? We're trying to find the cause. The cause, the full cause, the material, the efficient, the formal, the final cause. We're trying to figure out exactly what happened, the motive. The motive is part of the final cause. The formal cause, the material cause, the efficient cause, all of which went into this murder. All the stuff that you do in a murder investigation, we're trying to get to this key, and we will change possibly our list, our P2 as we're doing this. But again, it's all the same. It's just probability, judged in the same way. Once we stick a P and once we have a Q, even with all the tacit premises that we have, well, then it's fixed. Then we have our probability. But we must not forget the tacit premises that are there. Because we almost never write them down once we get going on these maths and so forth, that people think they're not there. It's a bad thing to do. Don't do that. All right, so this, it's always cause. I mean, that can't be the surprise. I don't think it's a surprise. That's what we're trying to do in science. We're trying to find the cause of things. We're trying to describe or explain cause, same thing. Predict, same thing. We're trying to say this is the way the world works. And here's why. And that's the cause. And so we're always trying to find cause. So that's our goal. But probability itself doesn't care about cause. I'm talking about something that's extra probability. It remains the case that once you fix a Q, and it's fixed, rigorously fixed, even if it's all subjective, and including all the tacit and implicit premises. And once you rigorously fix that P, the probability of P given Q is itself fixed. It's fully deducible. It doesn't mean that it's going to come to an exact number. That's easy enough to see, as we saw, and we'll see again and again. It doesn't mean that it has any number at all. I mean, it could just be a word like high or unlikely or anything like this, but it's still deduced. All right, that's the way logic works. So now I want to bring up one last topic. I think I have, no, that's it. I'm going to quit there. I wanted to bring up relevance and the difference between independence and everything, but I see I have ranted and raved for another almost a half an hour again. So we're going to move through this even more slowly than I thought. So your homework is, and I want you to think about this probability of P given Q. And I want you to think of something contentious about a P. And really what we're trying to solve here is, don't forget, like last week, we have a Q and E, where E itself doesn't give us P, but because this equals, by Bayes' theorem, probability of P given QE times the probability of Q given E. Remember that, we learned Bayes' theorem right off. We want evidence that we think is going to be high. We want this to be high or true, given observation or something like this, and we're interested in P. I want us to think of contentious P, in which the Q is, the P itself may not be contentious, I mean to say the evidence is. So for instance, we have nice and contentious, everybody knows you shouldn't talk about politics, so let's talk about politics. Let's have for our P that Biden wins the 2024 presidential election. I want you to think about how this does not have a probability by itself, and how the different evidence that you assume can change this probability. And in fact, you hear lots of discussion of people talking about this evidence, and about evidence that they think is high based on experience that they have. Observations, all this kind of a thing right there. And you may try to find, what everybody's trying to find, of course, is the cause. The Q that gives you the insight in exactly what will happen. In other words, if you know exactly what will happen, you know the causes of what will happen. Or at least you've been told the conditions that lead to these causes. So that's your homework. Think about that. And you can also read. I'm going to post an excerpt of uncertainty for this thing. And then next week, we might not get to the numbers because I want to do, it's extremely important we do relevance. So we'll get to that, and we may do numbers then maybe next week, or maybe or certainly the week after that. That's it for now. Thanks for watching. Please ask questions in the comments below, or send me an email or that kind of a thing, and I will get to them. Thank you very much. Oh, the links down below. You know where to find them.